Mr. Gates, Your Excellencies, dear colleagues, ladies and gentlemen, a warm welcome to Belgium. It's a huge honor to be here today to give this spotlight talk. And Mr. Gates, in your TED Talk of 2015, you said if anything kills over 10 million people in the next few decades, it is most likely to be a highly infectious virus. And unfortunately, you were right, because so far SARS-CoV-2 killed an estimated 15 million people. And Professor Piot, dear Peter, the title of your book is No Time to Lose. No time to lose against infectious diseases. And in your book you said we're not ready for the next pandemic. And you repeated that over and over again. But luckily, efficacious vaccines were available within a year of the start of the pandemic, which is one of the most remarkable achievements in medicine. And we also have now antiviral, we have now therapeutics for the treatment of COVID. But we should also realize that if a new pathogen is emerging in the future, that it may not always be possible to rapidly develop vaccines. Just think about HIV. HIV emerged in 1983, almost 40 years ago, and today we still do not have a vaccine against HIV, 40 years later. And also, at the moment that a new pathogen is emerging, and just think about SARS-CoV-2 in the beginning of 2020, you basically can only start making the vaccine at the time that you know the genetic code. And this was on the 10th of January 2020. So you should, before we have, once you know the code and before you have the vaccines available, you should have tools, you should have something at hand to be able to protect the people most at risk. And these can be antiviral drugs, pills to treat people. And the good thing is that you can do this, unlike for vaccines, you can do this in peacetime. Because every virus basically belongs to a family, whether we know the virus today or we don't know it yet, a virus that may emerge in the future, it will belong to a certain family. And of course, you all know the family of the coronaviruses. And before 2020, we knew 6 human coronaviruses. And you see on this tree, each branch represents a family. And so on the branch of the coronaviruses, we see these 6 viruses. And then came SARS-CoV-2. There it is. Then came SARS-CoV-2, the 7th one. So just imagine that we had years ago that we had developed pills, therapeutics, antivirals against these 6 human coronaviruses on the branch. We know for sure that these pills would have been active against SARS-CoV-2. And on the 10th of January, once we knew that this was a coronavirus, we could have shipped these pills to Wuhan to treat the people infected, and together with quarantine measures, of course. And also to treat the doctors and the nurses taking care of these patients, and to treat the household contacts. But there are more families on the tree. And let me just tell you something about this family of the paramyxoviruses, to which measles and mumps belongs. And within this family, we also have the group of the henipaviruses. And within these henipaviruses, we have pretty nasty pathogens. And we also know that bats are full of henipaviruses. So it might be that one day there is a spillover from bats into humans. And we should be prepared for that. And so with funding from the PATH initiative, we are starting right now in my lab a program to develop henipavirus inhibitors. And many other viruses on the branch, including influenza. And you know that in the past, influenza viruses have caused large pandemics. So also for flu, for influenza, we should have broader acting antivirals at hand stockpiled. So the question is, can we do this? And just remember HIV discovered and emerging in 1983. In the 80s, HIV was a death sentence. In the 90s, and because of very hard work, the first antiviral drugs, combination therapies, became available. And then people, when taking a handful of these drugs, could basically be protected against the effects of the infection with HIV. But the therapeutics became more and more potent, and today people with HIV can be treated with just one pill a day and they live a healthy life. And I'm proud to also say that one of the most widely used anti-HIV drugs in the world has been discovered in Leuven. But it's not only about pandemic preparedness, we also have a lot of neglected infections that today cause a lot of problems. And I give you 4 examples of topics on which we work in my lab, and the first one is dengue. Each year, 100 million people become sick because of dengue. Every minute somebody around this globe is hospitalized because of dengue. During outbreaks, the hospitals are being overwhelmed and there is no treatment for dengue. So with Wellcome Trust funding and then later joined by J&J, we developed an ultra-potent dengue inhibitor which is now in clinical studies at J&J. Another example on which we work on is rabies. Each year, still 60,000 people die of rabies. And once the virus is in the brain, once people have neurological symptoms, it is a death sentence. 100% of these people will die. Doctors can do nothing else than let these people die. And I think in 2020-22, that's unacceptable. And so in my lab, we're trying to develop also a therapeutics basically against rabies. Another example is hepatitis E. And you see this infection in regions with poor sanitation. You have about 3 million cases a year, and in particular in pregnant women, certainly in the 3rd semester, mortality is really high, 25 to 30%. And so together with J&J, we are trying to develop therapeutics against hepatitis E. And the last example that I want to give, if the pointer once. The pointer doesn't want. I will tell you already, so this is against polio, and according to the WHO, we need, in the polio endgame, we need potent antiviral drugs. And also, together with teams in Korea and now joined by Gilead, we have developed a very potent polio inhibitor that is also active against all antiviruses you can imagine. Now, to aid in the development of such drugs, we built a fully automated lab in a box. Here you see that we bring the virus into the box, and here we transfer the virus to the robotic platform. And this platform works 24 hours a day, also in the weekend, without complaining. And so far we have been able, for example, against SARS-CoV-2, to screen 2 million compounds to pick up a drug discovery program. And so capsid, we call it capsid, will be part of the virus bank. And dear Mr. De Croo, dear Prime Minister, in your State of the Union in 2021, you said that your government is making resources available for a new Belgian virus bank to switch faster in new pandemics. And I'm really honored that I can announce here today in your presence as well that we're currently building this virus bank in Leuven, and the capsid automated platform will be part of the virus bank. And the mission of the virus bank is to make sure that we have, for all these families of viruses, for all these branches on the tree, that we have standardized models and tools available to make sure that we can develop strategies, we and partner strategies against these viruses. And the government is also funding at the University of Antwerp an initiative of my dear colleague, Professor Pierre van Damme, Vaccinopolis. And Vaccinopolis is a state-of-the-art clinical research center for vaccine studies, for therapeutic studies, where also human challenge studies can be conducted. And this brings me back to the vaccines. In many places on this globe, it's really difficult to bring these vaccines cooled to the people that really need them. You need basically cool boxes and a lot of efforts to bring vaccines to these places. And so we want to contribute to that. And the approach that we use is to make use of the yellow fever vaccine. As you know, yellow fever vaccine is a fantastic vaccine. One shot gives within 2 weeks lifelong protection. But you need to produce this vaccine in fertilized chicken eggs, which is quite sort of cumbersome, and you need a cold chain. So what we did is, we took the genetic code of the yellow fever vaccine and we put it into a DNA circle. And that DNA circle, we can produce that in bacteria, which you can grow in large fermenters, which is a big difference with chicken eggs. And also, these DNA circles are highly thermostable. Now we can basically then, if you inject these DNA circles, and we have a lot of data in animals, it launches the yellow fever vaccine, and you get, in the end, the same protection as with the commercial vaccine. And we take it one step further, because what we also do is we insert into this backbone of the yellow fever vaccine. So we insert basically in this backbone, we insert foreign sequences, for example, from rabies, Ebola, Lassa, SARS-CoV-2. And this gives us dually acting vaccines that do not only work, for example, against rabies, but also against yellow fever. So to conclude, there is indeed no time to lose in the battle against viruses, but I believe that with science and sufficient efforts and dedication, that we will be able together to make the difference, that we will be able to win the battle against viruses. Thank you so much.